In this video, we're going to talk about whether the following series converges absolutely, converges conditionally, or doesn't converge at all and diverges. The first example I want to show is the sum of n from 2 to infinity of negative 1 to the n times sine pi over n. So the first thing you do when you look at this question is you check, we check for absolute convergence, because if it converges absolutely, then obviously it'll also converge conditionally. And so in order to check if this series converges absolutely, let's first make sure that as n approaches infinity, the actual series part, the sequence approaches 0. So limit as n approach infinity of sine pi over n approach equals 0, because sine 0 equals 0, and as n gets larger and larger, pi over n gets smaller and smaller. So the other thing you have to realize about this question is actually that as let's call it a goes to 0, sine a equals a. For very small values of a, we know that sine a for small values of a is equal to approximately a, and when that value gets very small, it's actually almost equal. So we can apply it in this case and say that the sum of sine pi over n is more or less equal to the sum of pi over n. And since this is a harmonic series, this is actually the harmonic series times pi, we know that this diverges. So we know that the absolute value of this series diverges. However, by the alternating sequence theorem, since we proved that the sequence goes to 0 as n goes to infinity, and we know that this is a decreasing function as n increases, we can say that this will actually converge conditionally. And will converge conditionally, because every alternating term every alternating term will have a negative sign, and so you'll have a bunch of negative terms going to infinity, as well as a bunch of positive terms summing up to infinity, and at some point they converge.